Alright, so we'll start here on the inverse variation. No, we have a faculty meeting this Monday to go over. The testing starts June 1st. What day? You don't know your birthday, or you just get it then? Alright, so inverse variation. There's an equation, y equals k over x. It's called the inverse variation equation. Now the inverse means that one thing goes up, the other goes down. So think about it as the more hours you spend playing video games, the lower your grade. Because one goes up, the other goes down. Or the more hours you spend exercising, the lower your weight. One goes up, the other goes down. Does that make sense? That's what inverse variation is. Because one goes up, the other goes down. One variable, whatever it is, it's an R, or I. As one variable goes up, the other goes down. So if you're looking at a line on a graph, it's going to have a negative slope. Or if you're looking at something like a real world example, it's going to go down. So that's like the general idea about inverse variation. Now the example that they give you here says, alright, suppose R is inversely proportional to S. Now this K here that they talk about, K is just a constant. It's the constant of variation is what they call it, or the constant of proportionality. So they're telling you as R is inversely proportional to S, R is negative 17 when S is 12. What is the value of R when S is negative 4? I have to do a split screen on this. Maybe I can. That's what? Okay, so over here we've got this is the equation for R is inversely proportional to S. So you've got to first know that inverse proportion equation. And what they're telling you is that you sit down, R is Y and S is X. So that's your equation. R is inversely proportional to S. And they're not always going to use Y and X. They're going to use different variables. That's why you got to know that where they go. So R is proportional to S. So it says, and it's kind of like a two-step thing. You've got to plug in the numbers first. So they give you R is negative 17 and S is 12. So you've got to first find K. So if you were looking at like steps, I need more room to write. If you were looking at steps, you would say plug into Y equals K over X. And your next step would be solve for K. Solve for K, that's constant. Solve for K, or solve for whichever one is missing. Sometimes they'll give you K and they'll give you S or whatever. I should say solve for the missing variable. And then your next step would be plug back in into Y equals AS, K over X, things called direct variation, indirect variation, adjoint, which you should have learned. Plug in the y equals table edge, solve for, normally you're solving for the constant with k. And you plug it back into whatever you got for k, and then use some more variables. So what we did here, we went ahead and plugged into the equation, and now we're solving for k, so that 12 is being divided, so we're going to come over here and multiply. So you're going to do 12 times negative 17. So that's negative, so negative 204 equals k. So we'll go step 1 and step 2. Caught up? Okay, so right here, so suppose R is inversely proportional to S. R is negative 17, S is 12. So that's when we plug that in right there. And it says, what is the value of R when S is negative 4? So we found K. Now we're going to take that K and that S and plug it back into here to find R. So we're going to say R equals the K, which is negative 204, over the S they gave us, negative 4, and it's divided. So negative 204 divided by negative 4. I think it's 61. And it's positive because the negative by negative. What do you think? It's in the problem. So R is 51. It should be. So what they got. Yeah, R is 51. Right, now here's a like a real world. Is everybody okay with that one? So I go to the next page. Right, so on this one it says, alright, times T, illustrates the destination by plane, varies inversely as the speed S. So I know that my equation is T equals K over S. That's the first thing. I know how to write that equation inversely. So write an equation that best models the time it will take to reach the destination by plane. So really, that's it. They've actually write the equation. They have to do that one. I don't know why. Anyway. Normally they'll say, okay, if it takes you 4 hours going at 200 miles an hour, how long will it take going 300 miles an hour or something like that? But they just wanted you to write that equation. That's all that one asked. So, anyway. I'd love to have that type of problem on the test. That'd be an easy one. Now here's one that's, okay, here's one that's looks more like it. Alright, so Boyle's law, anybody in physics or chemistry or anything like that? Boyle's law states the pressure P of a sample, the pressure P of a sample of a gas at a constant temperature varies inversely with the volume V. Okay, so P varies inversely, so I know V is in the bottom. There's my equation. So to find our equation, then we just plug in what they gave us. So the pressure of a gas in a container with a volume, you got to be careful here, the pressure of a gas in a container with a volume of 15 cubic inches. So this is V. So K over 16, the pressure is 24 psi. Somebody know what that stands for?
Pressure.
Yeah, so we do a pressure. Pounds per square inch. Really, to goodness, y'all looked at like the air in your tires. Do what? Yeah, in the gauge. Like when you, if you look on your tires, there's, I think this is where I feel like I feel like everybody needs to have a life skill class. How many of you know how to fix the tire pressure in your tires? You know how to change your tire. And you know how to, those are things that you need to know how. Anyway, if you look around your tires, there's a thing that'll tell you how much pressure should be in your tires. And different tires have different pressure.
What is that for again?
Pounds per square inch.
Oh.
The amount of pressure. Look on your tires. When you go out there, look around. If you look around with your tires, something else goes with bud. Your tire and your wheels are in here. There's stuff written right here on your tire. And I say that tells you the recommended amount of pressure in your tire. Do they know how to check the pressure in your tire?
Yeah, one little
There's a little gauge. You notice you hold it upside down, you don't hold it down like that. Y'all not, what am I saying? Y'all know what I'm talking about. Y'all know what I'm talking about? You don't hold it down. You hold it upside down, that way you get it accurately. Okay. Anyway, alright, so this was my drawing. Okay, anyway. So we plugged in. So we're solving for K. So we plugged in the equation. Now we're solving for K. So that's 16 divided. So 24 times 16, what's that? 384? Okay, so 384 equals K. So now we got K. Now it says if the pressure of a gas in a container is 64, so the pressure 64, we know K is 384. This time we're looking for the volume. Well, this one's a little different because what we're looking for is in the denominator. And we did one like this, but it's been quite a while back. The volume here, no matter what you're looking for, when it's in the denominator, we can do this a couple different ways. That's being divided, right? So the opposite of dividing is multiplying. So if we come over here and multiply by V on both sides, those cancel, and you get 64V equals 384. Wait, what's V is 16? No, that was the original one. It says the volume is 16 if the pressure is this. We want to know what's the volume if the pressure is this. So now, 64 and V are being multiplied, right? So the opposite is going to be to divide by 64. And you get 6 cubic inches, so inches cubed. But now, let me write this back over here and show you something else. This is what I showed you before. When whatever you're looking for is in the denominator, you can simply switch these two things. So put the V up here, put the 64 down here, and does that give you the exact same answer? 384 divided by 64, so it does. So you can think about it either way you want to. Just remember, anything you're solving for in the denominator has to come up top to the numerator. So you can think about, all right, I'm switching it kind of like cross multiplying. I'm switching these two things, or you can think, all right, that's being divided, so I've got to multiply by both sides. Then I got to get rid of the 64. However you want to look at it. Yeah. Well, K doesn't have any units. Right. Oh, okay. Thank you. I'll come by later on just to ask you, like, if you need to do more. Okay. Thank you. Yeah, it's okay. What I was saying, K doesn't have any units. It's just a constant, so there's no units on that one. I'm trying to say football. Who has that? Carly. So yeah, I'll need to know. But I mean, you're doing word problems, and you're doing the multiple choice, so they'll have units. So don't worry about that. Alright, we okay on that? Alright, so let's see. I think that's, and they go through this whole business of how to do this. Like here's where they did the V's in the denominator and they multiplied by V on this side and then they divided by 64. Same old thing that we did. Alright, so we're okay on the inverse variation then? Alright, now. I honestly, guys, I don't even know where to start. This is a whole, this is,
Yeah, I don't ever remember doing laws, ever.
um,
Yeah.
Why do we have to create it and then call it?
well, on a word problem, that's the create part. That, and then like this would just be a song, because they gave you the equation. I don't even know where to start on logs, because there's a whole, I mean, this is like a 3-day lesson here,
I
but
thought it was 0.
logs take quite a while to, I mean, if I taught it, it would, because there's different properties that you use, but we'll go through and I'll show it to you. No, just a regular delay. I don't even know. I can't believe y'all haven't done it.
Yeah, I don't ever remember doing laws.
Let's go back to this part, the trig stuff. Alright, so trig. Right triangle. You gotta have it with a right triangle. And remember, you have a leg, and a hypotenuse on your trig. And it all depends on where your angle is. But there are 3 trig ratios: sine, cosine, and tangent. And they call this symbol theta. The sine is opposite over hypotenuse. Cosine is adjacent. I'll write these out over here. Sine theta is opposite. It's the opposite side over the hypotenuse. This is chapter 7. I'm pretty sure it's chapter 7 stuff. Cosine of theta is adjacent, which is the side that it touches, adjacent over hypotenuse. And then tangent is opposite over adjacent. I didn't mean when I was talking about logs yesterday, I'm talking about logs last semester. Anyway, that's okay, we'll get to it. I'll let you get that and then I'll move on. I've been to all.
We're cold and we're hungry.
We good? Everybody got it? So I go on. Okay, so here's an example. Alright, so they're telling you in the problem if theta, or that angle, whatever you want to call it, theta. If theta is 25 degrees and Z is 10 inches, what is the value of Y? Alright, so here's your right angle, here's theta, and here's Y, here's Z, and here's theta. Alright, so with respect, we know theta is 25 and Z is 10. So the first thing I decide, with respect to this angle, a different color, with respect to this angle, that's the opposite side. Right? Opposite angle, opposite side. That's the opposite. This is across from the right angle, so this is the hypotenuse, and this is the angle that touches this side. So this is the adjacent. You okay with that? So opposite the angle, adjacent, it touches it, hypotenuse is across from it. So what have you been given? You've been given an angle, and you've been given a hypotenuse. So you have two choices here that you can do, but you're trying to find Y. So with Y, that's the opposite, and you've given the hypotenuse. So first I decide, am I using sine, cosine, or tangent? So you're using sine, because sine theta is opposite over hypotenuse. So we're going to plug in what they gave us. Another question? Okay. So the sine of 25 degrees equals the opposite over the hypotenuse 10. Alright, so now we're looking for the opposite. So remember, your calculator though has to be, make sure when you go to mode that you are in degrees. I'm going to raise it down there so I know the case. You've got to be in degrees. And make sure degrees is highlighted. And now I'm doing, that's where I was. I'm doing, that's being divided, so I'm just going to come over here and multiply. Try to get out of the way, Alex. 10 times sine of 25 degrees equals the opposite. So on your calculator, you're going to do 10 sine of 25. So over here, 10 25. As long as you're in degrees. So that's what that, and this fifth there is 10, isn't it? So that would be 4.2. So that 2 doesn't make that 2 go up. So 4, yeah, that's what they got, 4.2. This is what we did on the homework, and y'all hated it. Alright, so here's the next one. So we've got, here's our right angle. We've got 24, 40, 32, and here's theta. Alright, so they want to know, what's the cosine? It's kind of like a V. It's like a bird. You know when you're trying to draw birds and you're in the middle? Yeah, I know my bird. That's what I mean. So there's a bird. Cosine of the bird. Alright, so you've got to decide. Alright, here's my angle, right? So they want the cosine. So the cosine is, what's the cosine lambda is adjacent over hypotenuse. Right? So the cosine, the adjacent, here's the adjacent side that touches it, here's the hypotenuse. So we're doing cosine of 24 over 40. Now this one's a little different. You'll remember when we were looking for the angle, remember what we had to do? Some different on calculator. You gotta do the inverse cosine. So when you're doing this, you've got to say cosine inverse. Cosine of -1. You have to do second cosine. When you're finding the angle, you have to do this. 24 over 40. Tyler, you drawing or are you doing math here? Okay, hold on. Cosine of, what was it, 24 over 40? 24 over 40, enter. Alright, did they take the nearest 10 or anything? Oh, you know what, they didn't even ask us to do, I'm sorry, I should have read the directions. They didn't ask us to find the angle measure, they just wanted us to do the cosine. So I mean, what we were doing, here's the difference. When they, see where they just said, what is the cosine, they didn't say find the measure of the angle. What we did was find the measure of that angle, which is 53. They just wanted us to do 24 over 40 and then reduce it to 3 over 5. That's my fault, I didn't read the question like I should have. If they said find the angle, then it would have been 53. If they said just what's the cosine, it's 3 over 5. That was my fault. Alright, so let's try this. Okay, here's your real world problem. A scientist wants to measure the distance across a swamp. Okay, to do this, he selects the points A, B, C, and creates a triangle shown in here. Okay, so he wants to know this length right here. So, with respect to this angle, 23 degrees, is this opposite, adjacent, or hypotenuse? That's adjacent, because it's touching that. So this is the hypotenuse, this is the opposite, right? It's opposite. So we're looking at opposite over adjacent, which is which one? 10. Okay? Everybody, let me go through that again. So 23 degrees, we're looking at this angle. That's the opposite. And we're looking for this one, so this is the adjacent. So opposite over adjacent. So we're going to do tangent 23 equals 21 over, I'm just going to call that x. Okay? Yeah. Tangent 23 degrees equals 21 over x. Now here's exactly what I said. Here's where I said, remember when what you're looking for is in the denominator, you switch these two. So x equals 21 over tangent 23 degrees. Same on the spot, and they go this before. Alright, 1 decimal though. 7 makes the 4 go up to a 5. So 4, I don't even know if they asked us that. Let me see. If they go to a certain. They didn't even ask determine, again, I didn't read the equation. Determine an equation. Well, there's the equation. If they asked us to solve it, it would have been 49.5 meters, I guess. So they just want the equation. Okay, now, let's go. We're getting ready to do something, we'll see.
Yesterday was like the perfect. Oh, I know.
Alright, so it says, alright, Chris is constructing a diagram for a deck he's restructuring in his backyard. The deck will be in the shape of a square, and he has labeled a side length with the equation below, where x represents, hold on, let me see. Alright, it won't let me show the entire problem, so we're just going to switch back and forth. Alright, the deck will be in the shape of a square. He's labeled a side length with the equation below, where x represents the original deck area. Alright, so let's now remember square root x plus 12. So he's got a square. And he says, now we know the area is of a square. We can either say it's length times width, or we can say it's side squared, right? So he's labeled it the square root of x plus 12, right? And they're saying x is the area of the deck. Alright, so we know if that's x plus 12, then that's also x plus 12, right? So if we were doing the area of this, and we know that we can use sides squared for the square root of x plus 12, and we square that, right? Okay, well the square root of the square, what happens to those? They cancel, and we're left with just that. I don't know what the answers say there, but according to his equation, Chris wants to increase the area of the deck by 144 square feet, increase the length by 12, the perimeter of the deck, the area of the deck, the perimeter of the deck, the width of the deck. Well, look at what we got here.
The second one is
We've
wrong.
got the, okay, so we know the second one's wrong. So we got the area, hang up, put your feet down. They said the area was x, right? The area of the deck was x. So if this is the area, we're increasing it by 12, right? So it's all in what they, like they said, where x represents the original deck area. So if you've got your, here's your area, and you're increasing it by 12, so what would you pick here? That one? Alright, fingers crossed. Yay!
Got one right.
Got a 10.
From his lesson, he did this yesterday. It was like, you know, the pictures where it's like homework, or classwork with 2 letters too, and then homework, or the test, like, one has 6 apples.
Alright, so here's another one where they're talking about, you're talking about drawing a point line.
Yeah, like, what is it?
Okay, so it says Sharon's rowing a boat upstream. The river is flowing at a speed of 3 miles an hour. Per means that's your rate. Key word. 3 miles an hour. Sharon starts rowing at a speed of 8 miles an hour. But as she gets tired, her speed decreases at a rate of 1.5 miles per hour every hour. Graph the equation that fits the description where y represents Sharon's speed and x represents the time elapsed. Alright.
I have this exact, yeah, the line was increased by 2, so I put a point at the 8 or whatever it is, and went down by 2, and it was wrong.
What were you going to say, Sam?
Yeah.
Well,
We're studying on this too, like.
well, you gotta know how to do it though, that's the thing.
Is this a test?
Well, this will be your test.
It's easier doing stuff like this on paper than it is on the.
Where am I?
Okay, well, if it's easier doing this on paper, then do it on paper. How is it easier on paper? No, that logic doesn't follow. Alright, think about it. The river's flowing, think logically. The river's going at 3 miles an hour. So you're in a raft and you're going down the river, or whatever she's in. She's in a boat, and she's going upstream. So, alright, the river's going down this way, right? And it's flowing at 3 miles an hour. 3 MPH. And it's going this way, correct? Alright, now here's Sharon. She's in her boat. And she's got her oar in the water. Alright, now Sharon is going, she starts at a speed of 8 miles an hour, right? Alright, so she's going this way 8 miles an hour. Well, there's an idea. But as she gets tired, her speed decreases at a rate of 1.5 miles per hour every hour. Who knows? So would you agree that maybe she's going 5 miles an hour?
Yeah.
Okay. But as she starts out at 5 miles an hour. But as she gets tired, it goes down, right? Alright, graph the equation, let's see, she has her speed decreases at a rate of 1.5 miles per hour every hour. Graph the equation that fits the description where y represents Sharon's speed. So they're saying, okay, y is Sharon's speed equals, and x represents the time elapsed since the start of her workout. Yes?
How do you know how many hours you've been doing it?
Well, you're just graphing a line. The line goes on and on forever, so it doesn't matter. Alright, any ideas? Let's just take a guess at it. Start at 5. You can draw a line, graph the equation. Okay. Alright, y represents Sharon's speed, x represents time elapsed since the start of the workout. Alright, so, let me go back up. So we're going to start at 5 miles an hour.
Yeah.
Oh, let me put a point here. Alright, so if we start at 5 miles an hour, then what happens? It says her speed goes down. Where's the wrong one? It says at a rate of 1.5 miles an hour every hour. Right? So if she goes down 1.5, well that's 5. Are y'all saying go down 4.5 and then over a half? You know what I'm saying?
You go over 1.
Alright, think about this, 1.5, so if at 1.5, alright, she starts out at 5, 0, or at 0 hours, at 0 she's going 5 miles an hour, right? So in 1 hour, what's she going? 3.5, please do not get on your phone while I'm trying to explain this. 3.5, alright, so in 2 hours, what's she doing? 2. Remember, you're going down 1.5. So 2 and 3 hours, what's she doing?
25.
5. Alright, so could we graph the point? Remember that? 0, 5. Yeah. Alright, so 0, 5, and 2, 2, right? Yeah, so let's try that just a second. I didn't mean to do that. Okay. Alright, so 0, 5, and we said 2, 2. So if we did a line, you think that would work? You want to go with that? Now we said in 1 hour, 3.5, and 3 hours, 25. Does that line go through it? So in 1 hour, it's at 3.5. Let me get off that line. In 3 hours, she's at 25. So our line's going through it, isn't it? Yeah. Alright, so let's try. Okay. You're the one that said she went 5 miles an hour, right?
Yeah.
So in 0 hours, she was going 5 miles an hour. So, and then we made a little table here, and we said, okay, after 1 hour, she was going 3.5 miles an hour. In 2 hours, she was going 2 miles an hour. So all I did was plot 0, 5, and 2, 2, and I connected a line down through there. Yes, Jessica?
So the graph like this, you just skip the 0.5.
Yeah, because it won't let you graph the half thing. What you gotta do is find one that goes through a whole number.
Are there any graphs like this in the test?
On your test, you don't have to draw the graph, but they will give you 4 graphs, and they will say which one represents the description. So you'll have to choose a graph. And the other thing, they're not going to give you a graph that has 4 quadrants in it, because can she go back in time and row? No. Can she row at negative speed? No. So they're going to give you this part right here, but they will give you graphs. Alright, let's see. Next question.
Oh, no.
Here you go.
This is like 5, 10.
These aren't hard. Y'all give up before you ever start. You look at this and you're like, oh God, I'm scared. Think about these. Alright, Irene's invested P dollars. That's her starting amount into an account that earns Q percent. Alright, guys, am I going to do this, or are y'all going to? I'm not the one that needs to pray. Trying to help. Did anybody get this one yesterday?
No. I tried not to mark it, but I did not.
No, oh, I've already seen how much y'all did, I know. So, Nobody got this one?
I didn't do it yesterday.
I know. It's a zero. If it works out great, it's zero. Alright. Rings invested T dollars. They're just giving you letters instead of numbers. That's all they're doing. She's invested T dollars in an account that earns 2% interest, compounded annually. If Irene doesn't make any deposits or withdrawals, how much money would she have in the account after X years? Now, we've talked about linear equations. Y'all should know this one. We've talked about quadratic equations. And we've talked about exponential equations. So you have an initial investment, and you compound it. This is your rate. This is your time. They just use an R for how much is going to be in it. You may want to guess which one that this one would be. This one? This one? Derek has a square garden with a side length of X. If he decreases the garden length by 2 and increases the width by 2, what will be the new area of his garden? This one? Okay. Alright, he saves T dollars in an account that earns no interest. He deposits Q dollars per month. How much money would he have saved up after X month? First one? Okay. So then by default, that's that one. After your test. I'll probably be here until about 3:30, 3:45. Okay.